Today we will embark on a fascinating journey to explore the life and achievements of one of the greatest inventors in history, a man whose contributions have left an invaluable legacy not only for the society of his time, but also for the modern world in which we live. Among his most remarkable creations is the perpetual mechanism, a brilliant invention that continues to be widely used to this day. Present in most homes, businesses, offices, and residences around the globe, this innovation showcases the genius and vision of this extraordinary inventor, whose influence transcends generations and remains alive in the daily lives of millions of people. This story is a celebration not only of his ingenuity, but also of how human creativity can transform the world, shaping the present and paving the way for the future. Join us on this inspiring journey. Childhood and early talents. Alessandro Giuseppe Antonio Anastasio Volta was born on February 18, 1745, in the city of Como, in the Duchy of Milan, which was then under Austrian rule. He was the youngest of 7 children in a noble but financially declining family. His father, Filippo Volta, died when Alessandro was just 7 years old, leaving the family in a delicate financial situation. Despite these challenges, his mother, Donna Maddalena dei Conti Inzaghi, made great efforts to ensure that her children received an education. Even as a child, Volta showed signs of intellectual brilliance. Unlike his peers, he learned to read and write on his own and developed an early fascination with natural phenomena. By the age of 14, he had already begun experimenting with physics, especially with static electricity, a topic that would later define his career. He was educated at the Jesuit School in Como, where he was exposed to both classical literature and natural philosophy. His teachers initially pushed him toward a religious vocation, but Volta resisted. Instead, he focused on studying the sciences independently, guided by correspondence with other scholars and by extensive reading. The path to scientific discovery is 1774 or 1780. In 1774, Volta was appointed professor of physics at the Royal School of Como. That same year, he invented the electrophorus, a simple device capable of generating static electricity through induction. This invention was widely recognized and spread quickly throughout Europe. Although the concept had been hinted at by other researchers, Volta's version was practical and efficient, marking his first major contribution to the scientific world. In the following years, Volta expanded his studies to include atmospheric electricity and gases. In 1776, during a visit to a swamp near Angora, he discovered a flammable gas that he later identified as methane. Volta demonstrated that this gas could be ignited with an electric spark, thus opening the door to new understandings of chemical reactions and combustion. His works gained attention from academies across Europe, including the Royal Society of London, which elected him a corresponding member. He continued to refine instruments such as the condenser and the electrophorus, and began to design new devices to measure and control electrical phenomena. The invention of the voltaic pile, 1780-1800, the rivalry with Galvani, and the rise of electrochemistry. One of the most defining moments in Volta's scientific life occurred in the 1790s, when he entered into a famous debate with the Italian physician Luigi Galvani. Galvani had observed that the muscles of a frog twitched when touched with different types of metals, which led him to theorize that the animal possessed a form of animal electricity. Volta, however, disagreed with this interpretation. After a series of careful experiments, he concluded that the electricity came not from the animal tissue, but from the contact between different metals. He showed that by stacking alternating layers of zinc and copper, separated by pieces of cloth soaked in salt water, one could generate a steady flow of electricity. This invention, presented in 1800, became known as the voltaic pile, the first true battery. It was a revolutionary device because it allowed scientists to produce electricity in a controlled and continuous manner for the first time in history. The letter to the Royal Society and the scientific impact. Volta announced his discovery in a now famous letter addressed to Sir Joseph Banks, President of the Royal Society of London, dated March 20, 1800. In it, he meticulously described the structure of the voltaic pile and the procedures for replicating it. The response was immediate. Within weeks, scientists across Europe were building their own piles and conducting experiments that would lay the groundwork for electrochemistry. Volta's device overturned the dominant theory that electricity was a life force exclusive to living beings. For the first time, it was demonstrated that electricity could be generated chemically, and not just by friction or biological processes. This realization dramatically expanded the scope of scientific investigation. His work inspired others, such as William Nicholson and Anthony Carlisle, who used the voltaic pile to perform the first electrolysis of water, decomposing it into hydrogen and oxygen. The road to a new branch of science, electrochemistry, was opened thanks to Volta's invention. Recognition, retirement and legacy, 1800-1827, international acclaim and honors, 1800-1810. The invention of the voltaic pile catapulted Volta into international fame. Governments, scientific societies and universities acknowledged the importance of his work. In 1801, Napoleon Bonaparte invited Volta to Paris to present his invention before the French scientific elite. Volta's presentation to Napoleon and the Institut de France was a resounding success. Napoleon was so impressed that he awarded Volta the Légion d'honneur, appointed him as a count, and named him a senator of the newly formed Italian Republic. Volta also became a member of the French Academy of Sciences, the Royal Society, and numerous other academies. Despite these accolades, Volta remained modest and continued to teach physics and conduct research. From 1804 to 1819, he held the chair of experimental physics at the University of Pavia. During these years, he focused more on mentoring and teaching, passing his methods and ideas on to future generations of scientists. Retirement and final years, 1810-1827. In 1819, Volta retired from public life and withdrew to his country estate in Camnago near Como, a town that now bears the name Camnago Volta in his honor. He lived a peaceful and contemplative life, spending time with his family and maintaining a strong interest in science, though he no longer published extensively. Even in retirement, he maintained correspondence with fellow scientists and stayed informed about developments in the fields he helped create. He continued experimenting in a private laboratory, refining some of his earlier devices and encouraging younger physicists. Alessandro Volta died on March 5, 1827, at the age of 82. His death was mourned across Europe, and his legacy was immediately recognized as foundational to the modern scientific era. He was buried in Como, and a neoclassical museum, the Tempio Voltiano, was erected in his memory in 1928 to house his instruments and documents, a legacy of light, Volta's impact on science. Volta's influence extended far beyond his lifetime. His invention of the battery was the cornerstone for the development of electromagnetism, electrochemistry, and eventually electronics. His work made possible countless innovations: the telegraph, electric motors, radio, and even computers and smartphones. His methods also set a standard for scientific inquiry, combining theoretical knowledge with experimental precision. Volta's emphasis on empirical evidence and repeatable experiments influenced the scientific process for generations. In recognition of his contributions, the unit of electric potential, the volt, V, was named after him in 1881. His name thus became part of everyday language, embedded in every electrical system on the planet. From the 19th century to today, Volta and the birth of electrochemistry. With the voltaic pile, Volta provided scientists with a powerful tool to investigate chemical reactions driven by electric currents. The field of electrochemistry emerged as a result, and discoveries multiplied rapidly. Electrolysis became a fundamental method for analyzing chemical compounds. It allowed for the isolation of elements such as sodium, potassium, and calcium, all of which were first separated using voltaic currents. His invention not only contributed to physics and engineering, but also to the advancement of analytical chemistry and industrial processes. Although Volta didn't live to see all the applications of his work, he laid the groundwork for an entire field of knowledge. Technologies like metal plating, aluminum extraction, and fuel cells can trace their origins back to his invention. Volta in culture, education, and memory. Volta became not only a symbol of scientific progress, but also a cultural icon. His portrait appeared on Italian currency, postage stamps, and commemorative plaques. Streets, schools, and universities around the world have been named after him. The Tempio Voltiano in Como is now a museum that preserves his instruments and celebrates his life. The city also hosts scientific conferences and exhibitions in his honor. In Milan, the Museo Nazionale della Scienza e della Tecnologia Leonardo da Vinci includes a permanent exhibit dedicated to Volta ES work. His legacy continues to inspire scientists, engineers, and educators. Textbooks in schools teach the story of his discoveries, and laboratories around the world still use the basic principles of his pile in demonstrations and experiments. A timeless contribution. Alessandro Volta's work changed the world. By inventing the battery, he made electricity a tool that could be studied, harnessed, and used. His discovery launched a cascade of innovations that continue to shape our modern lives. In every electric light, in every battery-powered device, in every measurement of voltage, there is a piece of Volta's vision. He was a man of his time, yet his ideas transcended centuries. His humble beginnings, relentless curiosity, and scientific rigor remind us that profound change can come from the patient hands of a quiet thinker. Volta's name is not just written in the annals of science, it is inscribed in the daily pulse of modern civilization.